Good evening, everyone, and welcome to the Royal Academy of Engineering's discussion on the future of clean energy technology, which is the second in the Academy's Innovation Incoming series. My name is Hannah Previtz, and I'm Deputy Editor of the Times Enterprise Network, where I write about entrepreneurs and fast growth businesses for both the Times and the Sunday Times. And I'm delighted to be your host for this evening's event, which will take a look at some of the most promising technologies for clean energy. We will discuss what's needed to develop these and potential future innovations at the pace and scale required to achieve our national targets for decarbonisation and to tackle the global challenge of climate change. Given the Prime Minister's recent rowing back on some of the UK's net zero targets, this evening's event really couldn't be better timed, so bravo to the Academy for that one. This event is a MacRobert Award special, and we are joined this evening by Ceres Power, which won this year's MacRobert Award for its pioneering clean energy technology, which includes fuel cells for power generation and electrolyzers for green hydrogen, and we'll be hearing much more about that in just a few moments. But first, some quick points of housekeeping. So those of you that are here in person, welcome. But please remember that we are live streaming on LinkedIn, and also that the event is being recorded and will be posted online in the next few days. We aren't expecting any fire drills this evening, so should you hear a fire alarm, it is the real deal. So please follow the instructions of the Academy staff to safely lead you out of the building. Please keep your phones on silent for the duration of the event, but do feel free to post on X, the artist formerly known as Twitter, using the hashtag #InnovationIncoming. Audience questions are very welcome this evening. It's really good to make these events as interactive as possible. So everyone here in the room should use the Slido platform to ask questions. And those of you who are joining online, please type your question into the comments box on LinkedIn, and we will try to answer as many of those as we can. So getting back to the reason we're all here this evening, the MacRobert Award is the UK's longest running and most prestigious national prize for engineering innovation. Originally founded by the MacRobert Trust in 1969, the award is now presented and run by the Royal Academy of Engineering with generous support from the Worshipful Company of Engineers. The award is given in recognition of an outstanding innovation that has tangible societal benefit and proven commercial success. And the winning team receives a gold medal, a cash prize of £50,000 and a weekend away in Doonside House, which is in the heart of the MacRobert family estate in Aberdeenshire. And as if that isn't enough, you also might get featured in the likes of the Times, which Caroline did earlier this year. More recent winners are an illustrious company indeed. So the joint first winners in 1969 were Rolls-Royce for the Pegasus engine that powered the Harrier jump jets, and Freeman Fox and the partners for the aerodynamic deck of the Severn Bridge. Since then, the award has continued to seek out and champion the best of British innovation, and many of these products and technologies have helped to change the world for the better. Of course, it's only in more recent decades, and in light of the growing evidence on climate change, that the need for clean energy technology has become so apparent. But engineers will always rise to a challenge, which I'm sure many of you in this room will attest, and always try to come up with solutions to the world's problems, which is why Ceres Power is such an exciting winner this year. Supporting and celebrating enterprise innovation and skills across the UK is a vital part of the Academy's work, and the award fits extremely well within the Academy's wider portfolio of activities aimed at harnessing the power of engineering and technology to build a sustainable society and an inclusive economy that works for everyone. So without further ado, it's now my great pleasure to welcome our first guest this evening, Dr. Caroline Hargrove, CBE, Fellow of the Royal Academy of Engineering and Chief Technology Officer at Ceres Power. Caroline, please do join me up here on stage. And whilst we do that, let's watch a short video about this year's MacRobert Award winner, Ceres Power.
At Ceres, we've developed technology to decarbonize the really hard to decarbonize areas. What is unique with Ceres' fuel cell is it can use a number of different fuels to produce electricity. And without a change, that same technology in reverse, if you've got green electricity, will produce green hydrogen in the most efficient way today.
So what Ceres makes is a device that converts electrons to molecules and molecules like fuels into zero carbon electricity. And so a device that can make zero carbon hydrogen is a cornerstone of the energy transition.
This technology hasn't been done before because it's hard. It's really difficult. We take the positives of the high temperature fuel cells and a lot of the positives of the low temperature fuel cells like robustness and low cost. And therefore we have a technology that is way more efficient, way more robust and way more affordable that can really decarbonize the hard to abate sectors.
The number of skills we require to engineer it, from material scientists through structures, mechanical engineers, chemistry and everything in between. The smallest features in our cells you could measure in the tens of nanometers, so 1% of a human hair. And then the biggest problems we look at are things that relate to how we put these things onto container ships. So we go from the very smallest parts of engineering to the very biggest parts of engineering. And for me, that's just so exciting.
These Ceres technology electrolyzers show the lowest conversion losses that I've come across. They are spectacularly efficient. That is a huge game changer for hydrogen generation. It's very exciting.
Well, good evening, everyone. First thing I'm going to say is I'm here representing a team and we're thrilled to have won the MacRobert Award. This is representing a big achievement, a company that is now nearly 600 people. And considering we started about 23 years ago, and Nigel Brandon, who's in the room here, is one of our founders, and we're a spin out of Imperial College. I brought the fruit pops for those of you in the room afterwards if you want to come and see, but just to give you an idea, we started off with cells this size, button cells, and over the years tried to develop the technology not just to make it work and to be efficient, but to make them bigger, therefore more practical, reduce the steps, the manufacturing steps, and now we've evolved in something much more commercializable. And the point I want to make here is this happened over many, many years, and therefore there's a lot of people that have contributed to the success of Ceres where we are today, and there's still plenty more to do because we reach a stage where this technology is developed and is only just being scaled, and this is where it's going to have an impact, is when it's being manufactured. We're a licensing company, so we rely on others to take this technology to market. And this is the time that is actually the most, I'd say, anxious to see how the impact that we can have around the world, because our technology partners are not in the UK, they're outside. We have Bosch in Germany building a plant, and Doosan in Korea building one right now, so it's exciting. But it is the work of many scientists and engineers, and we want to say thank you to the Academy to recognize it. We're thrilled. Thank you.
Please do. So thank you for setting the scene so beautifully, Caroline, and for acknowledging all the hard work that's gone into getting to this stage. Why don't we start by you explaining a bit more about the technology, so to somebody like me and others in the audience who might not know exactly how it works.
So the origin of our technology is in fuel cells. A fuel cell is a little bit like a battery that keeps going, because you put fuel in, and it's the similar electrochemical device, but with the fuel you constantly produce your electricity. So that people who don't know what a fuel cell is, and what a solid oxide one, which is what we do in our technology, is actually one where, by definition, the name and what I've showed you, it's solid. It's not what many batteries will be, but it also works at a much higher temperature. And what we were saying in the video just now is that what's unique is that when you're running at quite high temperature, you can reach so much higher efficiency. And the existing technology at a high efficiency scale were running at such a high temperature that you then needed specialist materials like very expensive glass gaskets and so on. And you can imagine just by mentioning the word glass that it's not so robust. And if you really want to make a game-changing technology, it has to be usable practically, not just in the lab. And that's something that was the spark, the USP of this technology, is to make something that can have the positives of a high temperature fuel cell, but with a lot more common materials like automotive style gaskets and so on, so that it means that it's manufacturable at scale at a much more affordable price. It's mainly steel, and so it's from a recyclability, it's also really important. It's not just that, obviously. It's in a similar way as any batteries. There'll be an anode, an electrolyte, and a cathode. The key USP again was the choice of that material, and that's what gave the name of the company. So there's a Ceres oxide in there, hence Ceres Power. So that allowed not just the fact that we can run at about 600 degrees C, but the fact that you can manufacture it and deposit it at a temperature that you don't melt the steel. So therefore, there's a lot of positives here. And what's been tremendous is that each one of those steps required a lot of development. So you need the vision, and you need the staying power, you need the belief by all the scientists and the engineers to make this work. And that's where electrochemistry is not something that can be developed very, very quickly. And that's why I was saying in the video, it's hard, it's a difficult problem, but it attracts people who like solving difficult problems, but it also attracts people that want the mission. And so we have a team of dedicated scientists, engineers who really want to make this work. So it's actually, I have to say, a really great place to work.
And one of the things that we're going to talk about later is kind of investment. And in the UK, historically, we haven't been very good at investing in kind of companies with longer term visions that are going to take longer to realise than the typical kind of 3 to 5 years in which investors want their cash back. How much investment have you raised to get to this point?
Well, like many companies, it hasn't been a straight line to where we are now. It had its ups and downs. It had a big down about 10 years ago or so, and a reevaluation of how to make this company work, because trying to do everything. Now, we've all got to realize that in this world of clean tech, it's the demand for this is also something that has to be there, and we all know that we kind of needed it, but now people want it yesterday, but that wasn't always the case. And creating that demand helps to get the funding and so on, but also need how to scale this, how to manufacturing a scale. Trying to do that and do the R&D was really difficult. So what happened about 10 years ago is IP Group stepped in. We got some funding to reboot with a different business model, which was to do a licensing model. And that allowed us to concentrate on the technology development and seek partners to help with the scale up, and use partners who are used to building big factories at scale and have the balance sheet to do that. So it was also a way for us to essentially get out of this funding issue that we have to do everything ourselves. Mm-hmm. Now, things have changed and so on, and it's not I'm not saying it's good for everyone, but at the moment, certainly there's other companies who are also trying to do this licensing model, but it is a way that we certainly hope will allow more of these the impact of our technology to be greater, because a number of people can license our technologies in a number of different places around the world and build a number of factories. We need, the demand for, if we just look at hydrogen alone, the demand that most think tanks are saying is huge. It's like 3,500 gigawatts required, and we have one. gigawatts at the moment deployed in the world. Like, this is the gap that there is. So you'd have to like put 100 gigawatts a year to just catch up. We're not going to do that, right, immediately. So it's not that the demand is not there, but you have to get the whole ecosystem. And you were talking about the funding. It's not just funding the technology, but funding the people building the factories, building the whole of the changing these long-term investments for the off-takers of the hydrogen, etc. So there's a lot that needs to happen together. The technology is one step.
Well, thank you for lining up so beautifully so many of the points we're going to discuss in just a few moments. But before we do, in terms of the MacRobert Award itself, what does, just in a few sentences, what does that mean to the team at Ceres? You know, how excited were you to receive this very prestigious award?
We were over the moon. I mean, it's hard to say because people think, oh, you know, it's an engineering prize and so on, but it is the top prize that the UK gives. It's the accolade that you receive from others. We were thrilled to bits. The other people who've won it in the past show the history of this prize, but it's also the fact that it's being recognized by peers, by people that have, you know, a lot of experience doing this. And I've looked at our technology. It feels like it's like someone saying, yeah, you know, this is good, keep going, in a way that you don't get in, you know, we are always trying to convince our future partners that our technology is amazing. But this time we weren't trying to sell it to someone to buy, but it was someone kind of almost, you know, coming in and marking our homework. And it was lovely to see that we got an A+, you know. It's just like we were thrilled.
Well, congratulations again. Thank you very much, Caroline, for those thoughts. So I'm now going to invite our other panellists to join us up here on stage. If you'd like to come round, whilst you do that, I'm going to introduce each of you. So we're now going to be joined by Sir Richard Friend, who's Fellow of the Academy here, Professor of Physics at the University of Cambridge and Chair of the MacRobert Award judging panel, so he can tell us all how we can win in future years. So Richard and his colleagues actually won the MacRobert Award back in 2002 for organic light-emitting diodes, which was developed by Cambridge Display Technology. To Caroline's right here, we have Professor Mercedes Morato Valla. I hope I didn't ruin your name too much. Director of the UK Industrial Decarbonisation Research and Innovation Centre. She is also Deputy Principal for Global Sustainability at Heriot-Watt University, leading on their sustainability agenda. So welcome very much. Welcome to this evening, Mercedes. And last but not least, we have Pippa Gawley, who's founding partner of Zero Carbon Capital. Pippa and her co-founder, Alex Gawley, founded Zero Carbon Capital in 2019, I think I'm right in saying, with the mission of alleviating the funding gap that we're going to talk about in just a minute for deep tech climate startups. So to the new panellists that have just joined us, I'd love to hear a bit more about each of your backgrounds. And what developments in clean tech excite you the most and have the power to change the world? Mercedes, a big question, but I'm going to come to you first.
Thank you. Well, thank you very much for the invitation to be here, and I think obviously big congratulations to Ceres, they well deserved, and particularly because it's something that comes from university and academia, and then you can see growing. So it's really, really good to see that. So congratulations and well deserved. As you were saying in the introduction, so I'm the director of the Industrial Decarbonisation Research and Innovation Centre, a very long name, and we were able to abbreviate it just by IDREC, so that we were very fortunate on that. But really what is important with IDREC is that we are working with the largest industrial clusters in the UK, and that means that we take quite cross-sectorial approach, all the way from cement to plastics to pharmaceuticals to petrochemicals, and we help them to decarbonize. And I think in this journey of decarbonisation, we do need to have, you know, smashing technologies like Ceres. We definitely need that. But technology alone is not going to do it. And that's what I'm coming to answer your question, actually, Hannah. Technology alone is not going to do it. We need to have the business models. And I think that was something you were kind of leading into that, Caroline, as well. We need to have the policy, the regulatory frameworks. And all this has to come together. So the way we are approaching this in ITRIC is through a whole systems approach that now has become very fashionable, but we kind of spearheaded a little bit the idea of putting different technologies, starting from a technology agnostic point of view, understanding what the industries need, and then how we can provide the solution package that includes, as I was saying, the technology, but many other areas as well. And is that really what it makes me excited now, just to see that technologies like what we just hear, they can be hopefully packaged together with a business model, with a regulatory framework. And then something that I'm particularly excited, and it sort of builds on the technology that we heard, is around the conversion of CO2 into chemicals and fuels. CO2 we know for all the wrong reasons, unfortunately, but at the end of the day, carbon is probably everything that you see or you are touching in the room. Actually, there is carbon into that. Even if you're touching yourself, you know, we are all made of carbon as well. So that I think that it's important that we acknowledge that sometimes it's not about decarbonization, but it's about defossilization. And carbon and CO2 can actually have huge benefits. Particularly one area that really I find inspiring is around sustainable aviation fuels, and how we can build from technologies like Ceres together with other technologies that you can group together into a system, into a process, and have sustainable aviation fuels, what is one of the hardest sectors to decarbonize as well.
Well, thank you very much for that, Mercedes. And we could go, you know, down a route of kind of, you know, cement that captures carbon and, you know, lots of fascinating technologies. But I'm going to move on to Pippa. I'd love to hear a bit about your perspective, why you set up the fund when you did. We talked last year about the lack of access to patient capital here in the UK, and I think that's something that you spotted. And I know it's like choosing your favourite children, but perhaps you could just give us a glimpse into a couple of your portfolio companies and the technologies that kind of get you excited because of their impact, I guess, more so than the technology per se.
Yeah, so we set up the fund initially. I started investing as an angel investor in the US and saw there, you know, a really different environment from the UK, and you know, a lot of vision and ambition about using technology to solve big problems, and the funding partners and the kind of government partners and the regulatory environment that was needed to support them. And then we were there during the Trump era, so that was pretty devastating to see what can happen when some of that falls away. And then, you know, when we came back to the UK, we kind of felt that there was a lot that we'd seen happen in the US, particularly the climate tech space, that would happen here too. And we just had to take a bit of a leap of faith that we would catch up in certain areas. We already had, you know, fantastic universities and scientists, great government support, consumer support, but you know, there were some other areas in terms of like the VCs focusing on fintech more than on actual kind of hard science solutions, and a lot of the entrepreneurs have been kind of pushed into taking more risk-averse positions, like looking to make the return, you know, 2x return in 3 years, which is not going to get you, you know, real innovation in technologies. So we kind of set up a first fund to prove out the concept that we could find that kind of entrepreneur here in the UK with the big visions and the breakthrough technologies that we need to solve some of the unsolved problems of decarbonisation. And did that, invested in 7 companies across the UK, and we're now raising and investing from a second fund, investing across Europe, because we think we don't have all of the answers, a lot of them, but we think there's a lot more opportunities out there that we're trying to support. So we did that. You know, I was driven really to try and have the biggest impact I could have on the issue of climate change. I'm a proud engineer by education. I've worked a lot in a lot of different industries and managerial roles, so I felt I had the kind of combination of love of technology and appreciation of business as a tool to scale quickly, that we needed to have that impact, and really loved the spirit of investing to like have to try and understand the technology the company is developing and how we can best support them is you know, just a constant challenge. So much to learn and to help with. It's really stimulating. So we're really privileged to do that. And when we see the companies that we're investing in, which are the next kind of wave of innovations that we're going to need. You know, we often try and frame the climate change fight as like, we know what we need to do in the next 10 years to halve emissions, or kind of 7 years now to 2030. We just need to get on and do that. And a lot of that is the issues with scaling, it's the regulatory environment. You know, it's making sure we can roll out things as quickly as possible, like wind, like solar, like these technologies we have already that are the cheapest in the world. But what do we do next? And the next halving of emissions after that, we start to get into areas where we don't actually know how to decarbonise them yet. And that's across all the different sectors. You know, everything from, great, we've got wind and solar, but, you know, what do we do when we need to store energy? How do we keep the frequency regulated? How do we make sure we've got enough capacity and flexibility in the grid? You know, and then food and agriculture, like virtually all of that is unsolved when we look at the problems from everything from land use change to fertilizer usage to livestock farming. You know, there's so many opportunities there for us to get involved from a technology perspective. I know we could go on, but yeah, some of the areas we're most excited about are the decarbonisation of industry. So the use of alternative fuels like hydrogen and ammonia to achieve some of the heats that we need to produce the things that we use. The use of alternative feedstocks, so we're looking a lot at carbon supply chains, so not just carbon dioxide, but, you know, biomass, algae, you know, what other carbon producing things can we leverage to produce the carbons that we need for various chemicals and fuels. We're looking, you know, very broadly across things like direct air capture as well. So, you know, we know that we are going to need to, again, this is kind of getting into the last set of halving from 2040 to 2050. There's going to be a lot more emphasis then on doing that, trying to undo some of that damage that's out there in terms of scaling up the technologies to sort of clean up the carbon in the atmosphere and in the seas. So, you know, we're looking very broadly across all of those areas and trying to spot where we think technology innovation can get rid of a barrier to adoption of decarbonisation.
Thank you, Pippa. And Richard, to you. So obviously you wear many different hats, you can't possibly count them all. And you encounter lots of very kind of smart people along that way. So Pippa was saying we don't have all the answers in the UK. Do we have all the answers in the UK? Do you think we could solve this issue single-handedly? And what are some of the building blocks that need to be put in place? Policies come up, I think, throughout this entire conversation so far. So what else can be done in that domain?
Well, the biggest challenge that we run across is finding the right people with the right skills. I think anyone trying to build a company or even a university, you're just constantly stretching to get the talent. If you have the talent, you can do wonderful things. So I think making the UK as attractive as possible to attract and retain global talent, everywhere from the more fundamental work through to the scale-up of the manufacturing, is the absolute foundation of building, you know, a new economy. I mean, the transformation of energy and transport to zero carbon is going to be the largest disruption to our industrial structure in a century, and we need to make sure that we get the skills and the value landed in the UK, and that means people.
Mm-hmm. And so 2 points on that. One, I'm going to bring up the dreaded B word already in this discussion and ask, you know, I'll ask a couple of you if you think that's, you know, affected our attractiveness as a place for, you know, skilled people to come and work. And also another bone of contention. So I mentioned in my opening comments about Rishi Sunak, you know, him rowing back on promises and pledges like that. Does that harm our kind of standing internationally?
I've
come to you because I know you'll give me an honest answer.
Well, the first thing is that when we were in the EU, for our R&D world, we absolutely made it work to our advantage. We were a very attractive destination for a lot of talent. We are not at the moment. I have to say a lot of the internal political debate that we've been through was listened to by all the people there in Europe who actually speak and read very good English. And I've had some very disappointing conversations when I've been around in Europe, because we have a lot of work to do to get us back to where we once were, where we did it very well. There are a lot of excellent, the educational structure across much of Europe is excellent. There is talent we want. We need to get it back.
Okay, I'm going to come to Caroline on the point of Brexit, but you're not off the hook. So on Rishi Sunak kind of rowing back on the pledges, does that kind of signal something else again to our counterparts around the world?
Well, it doesn't help, but I think the message that needs to be put across is, even if you're a climate change denier, and there are still some around, if you look at the trajectory for where technology is going, if you look in the UK, we've done North Sea oil, we've learned how to do marine technology pretty well, we've got lots of relatively windy, shallow sea. The next opportunity for us is to make wind work. Solar has its role too, storage has to work. They're things we should be doing anyway, and we need a very clear message from government that that is where the UK is going. So what the Prime Minister said, I'm not sure exactly how to interpret it, but it wasn't the sort of encouraging message that we should be putting out about the UK's huge geographical advantage to be able to get renewable energy and all the associated industries that go with it firmly in our long-term plans.
Okay, thank you, Richard. So Caroline, I'm going to come
Can
to
I
you.
jump on this
Yes,
one?
absolutely, please do.
Well, because we actually made it to the main market in the summer, and just last week we made it to the FTSE 250, and with this announcement our share price went poof. Obviously it would, because it shows that there's no trust, there's no investment security in green transition, because the government then changed it. So it is tangible. We saw it immediately on the day of the announcement. So what we're saying is it's not that it's not going to kill the company, but it is remarkable that when climate change is happening, and we felt it, this is the warmest August on record by a mile everywhere in the planet, etc., etc. I mean, we should be doing more, and we look like we're doing less. I mean, I'm outraged, as you can tell.
Absolutely, joined by lots of people in this room, I suspect. And also just the impact on kind of sentiment, I guess, within a company like Ceres, 600 people all pulling together towards this common goal, to then see the Prime Minister say something silly like that is, I'm sure it's very detrimental to kind of the, culture within the organisation, or rather the morale. Anyway, so on the point of Brexit, what impact has that had, and how do you make sure you're still kind of attractive for skilled people to come here and work with you?
It has definitely made it harder to recruit. It's a tough market, because on the plus side there are a number of startups and so on in this area, but then it means that people are fighting for the right talent. But we have over 35 nationalities. Ceres, it's something that we're proud of, but it's not easy. It's not easy to do that. We have to apply for work permits, all extra work. But even on the practical side, as I mentioned before, one of our licensees is Bosch. Now, just to get their systems over to us, it's hard, because the regulation is different. I mean, it's just like, really, it's a shame, but it makes it hard just to test, because if you certify it in Europe, it's not the same. Now we have to certify it in the UK separately. That just makes it harder. When you want to be an international company, I find that obviously very frustrating. You live with it, but these are things that will take a while. We just have to somehow pick up the pieces and just move on. And it's I'm not sure that we've seen a lot of any positives, if I can say that, from this move.
But as you say, kind of entrepreneurs and founders tend to be optimists, right? So I'm sure that you will rise to the challenge at Ceres and other companies. So Mercedes, I'd love to come to you next on this point around policy. So, you know, how do you see the regulatory framework could be perhaps improved to support the next generation of clean tech startups?
So, we talk a lot with our stakeholders across industrial clusters, and the two things that they ask when it comes to policy is predictability and stability. You need to have those two, because then you can plan. And I think the energy transition, and one thing that we forget or tend to forget when we talk about energy transition, that is precisely that, it's a transition. It's going to take us time to get there. We talked before about patient capital, and that's really critical to happen here. You're not going to see those returns of the investment coming very quickly. And again, looking at industrial clusters, these are major infrastructure projects that they have to be completed and developed, and it's going to take time for that. Many of the large corporations, when they look in terms of investment cycles, there may only be 2-3 max investment cycles from now to 2050. So I think somehow we need to get all these messages in terms of the timeliness at which we need to take decisions, and how those decisions actually we need to stay. Because if we keep changing the rules halfway through the game and only the other team knows that they have been changed, because sometimes that happens too, it creates a market that is not stable and is not predictable. I think in terms of one of the things that we try to do in IDRIC, in the center, and I think we've done that quite successfully actually, this is not about the policymakers to try to figure it out, and this is not about the scientists to do. I think it's really about bringing all this ecosystem together. It's really about how we can very actively engage in providing that evidence, or tell our policymakers that there is a lack of evidence, and that's something that we need to work together to develop. But I think it's part of the problem here is that we don't communicate and we don't work together as closely as we should be doing. There is quite a lot of silos, quite compartmentalized, and we're talking a lot about policy, but it's really, at this point, quite a lot of the large projects that we work with, the biggest barrier that they have at this point is really the permitting and the planning. A lot of these large projects are coming to what we call the final investment decision, and they will not be able to push forward because actually the permitting and the planning is not in place. And this is not being interpreted like the regulators are trying to be difficult. We are moving into quite uncharted waters with new technologies and new ways to build things that we have not done before. So it goes back to my point, I think, is we take all these different sectors that they work and they have to think in isolation how this transition is going to happen, and we need to bring them together a lot closer and a lot sooner for this actually to really pick the pace and the scale that we need.
Mm-hmm. And Pippa, on that kind of ecosystem point, how do you work with other partners and, you know, organisations within the ecosystem when you're making investments?
Yeah, we're very collaborative because we invest at a very early stage. Often the companies we invest in will have come out of a university or a technology centre or a research institute of some subscription. We're often working then with other ecosystem partners to help them develop skills that they might not have. So, incubators, accelerators, venture builders who are helping them to develop those commercial skills. Or maybe it's more on the kind of the technical scale-up side, like developing their manufacturing capability. Then we collaborate with other funds in terms of, we think that's the largest area that we can make a difference, is helping them to get ready for their next round of investment and making sure that happens. So we have a lot of relationships with those kind of later stage investors. So we can kind of help to pass on the baton to investors who are going to help that company achieve their impact, and keep that climate vision strong in the company and not kind of push them into pivoting into something that might have a quicker return, if that's relevant for that company.
And what tends to catch your eye if there's anybody who's looking for investment at the moment and they're going to hit you up on LinkedIn after this? How should they pique your interest?
So, the same is true for pretty much any VCs. They're looking for somebody who's solving a big problem. So, we see thousands of decks every year from companies who are, they've got a brilliant technology and then they're kind of looking for an application, which is often not going to make a very valuable company. So we look for entrepreneurs who really understand a problem. They've got a real insight about it, and then they've developed a solution which is going to solve that problem. And they want to build a big, valuable company around that. Not just kind of make a quick exit. So, that's how we think we'll have the best chance of fixing climate change, and of that company becoming, a great return for our investors as well.
And what about, so the founder, so as a journalist, I'm always hearing from investors, it's all about the founder or the founding team.
Yes.
And something we've discussed on this stage before, and Richard and I have talked about, is about the skills of the founder and the fact that sometimes people from academic backgrounds, nobody shoot me, they don't always make the most commercial people. Lots of academics have told me this themselves, although some do go on and be very successful, but often they'll be paired with co-founders or with founding teams to, I guess, give those additional skills. So what's your experience of this, Pippa? And do you help them, I guess, kind of plug the gaps or to nurture them?
Yeah, for sure. And, it's, you do often get a scientist who's being paired with an MBA, like in some venture studio. And, sometimes that can be brilliant. But sometimes it can be a bit of an arranged marriage, and ultimately the kind of founding a company with somebody should be like a really long-term commitment. And if the people don't know each other very well, and really know that they're balancing out each other's strengths and weaknesses, then you can be setting up more problems than you're solving. So we particularly like teams who do know each other well, from whatever reason. They've studied together, they've worked together, they've been friends together. For a while, so they really know that they're complementing each other. They understand what skills are required to run a business, and we look for there to be the scientific know-how in the company to optimize the technology, and the skills to run a company. We absolutely think that can be learned, and pretty much learned on the job. Some of the best entrepreneurs in the world have done that, but we need to see that the entrepreneurs have got the capability and the willingness to do that learning as they're building their company. We love a good venture scientist, but we're fine as well with that being two different people with different skill sets, as long as the team as a whole has got that yin and yang about them.
Caroline, I can see you jumping out of your seat here to add something, and then we're going to come to some audience questions. So what would you like to add?
Yeah, I want to do a plug for the Royal Academy of Engineering, because I'm also on the Enterprise Hub for the Academy, and it's exactly what it's trying to do. There is to find academics or recent graduates and give them skills based on the entrepreneur and not the company. And that's quite unique. And this is exactly the problem that the Enterprise Hub is addressing, I think with success, but we're often having these discussions, and we had some today, very fruitful ones. But I'm glad that you're raising this point, Pippa, because this is exactly the kind of thing that I agree. We have great minds, and it's possible to do something great on business as well, not just on the technical side. And let's help those people who really want to give it a go as well. So I'm 100% with you.
Well, there's too much agreement happening in this panel. Let's see if we can mix things up a bit. So I have a question here from Luke Saunders. I'm not sure if you're in the room or joining us remotely, Luke, but Luke says, does the panel believe that UK clean energy projects can be made as attractive a resource for the government to invest in as oil fields like Rosebank seem to be? Very topical indeed. So who would like to take that one? How about Mercedes? Would you like to take that one?
I can start. I think this has been mentioned before already. These clean energy technologies, they are going to be more costly to start with. I think actually cost is the wrong word to say here. We need to be looking in terms of an investment in these technologies, because they are going to be significant returns of investment. But as with any technology that is emerging and is new in the market, it's actually quite difficult to compete with established ones. And then this becomes an issue then, do we have, going back maybe to policy again, but do we have policy parity across technologies? And policy parity here, it doesn't actually mean the same apply to everything. So we need to be thinking in terms of how we can create policy parity across different technologies, so we can actually give them a space to flourish and mature. if we think in terms of I said before, the transition is not going to happen just because you flick a switch. It's going to take time. And I think during that time, the same as we saw with renewables, that they were very heavily subsidized to get them off the market and to get them mature, we are probably going to see something similar in other emerging technologies. I think ultimately what we should be thinking is that the opportunity is going to be for whoever captures that opportunity. We have talked about Brexit, but we could be thinking rather than just within Brexit and Europe in a global market. We know with America and the Inflation Reduction Act, they really have changed the dial quite a bit in terms of where companies can go and invest. 1st of October, so on Sunday, we actually have in Europe become effective the carbon border adjustment mechanisms, the CBAM. That means that if you are exporting hydrogen, you actually have to demonstrate the green credentials or pay a tariff for that. So I think sometimes we get too hung up in terms of Brexit. I think is what we need to think is this is actually a global market and there are actually big players already making moves. And for me, what is not clear is how we are positioning within the UK to support the technologies and create that ecosystem for investors to come and pick them up.
Does anyone want to add anything to this before I jump to our next question, which is sort of related? Richard?
I'll wait for the next question.
Okay. Now you've nominated yourself to answer this one. So the way to net zero is definitely a global challenge. How the UK and the EU, brackets, let's assume we are together here with a wry smile, how could that influence the rest of the world? So I guess the question here is about how we are on a kind of global stage and how the rest of the world views us. Caroline?
Right. Just to say that all our partners are not in the UK and they think this technology is worth investing in shows that we can do this, right? So I'm 100%, I'm not worried when I said about Brexit, it's mainly for getting talent in. I think our technology is absolutely global and so I don't worry about this, but I do agree that most of the companies that invest in us got funding from areas like the EU or Korea. Korea are really big on fuel cells and electrolyzers. Japan gives subsidies, the US, and so there's a lot of companies, there are a lot of countries that do that. So it's helping us indirectly, but we're not getting any of that support in the UK.
The question is what difference does Europe, including us, make, I think?
Yes.
I'm really optimistic about how the cost of renewables has come down much faster than people thought it was going to. I mean, it's quite an interesting game to work out how much lower the cost for solar and wind can get. And there are optimists who think that solar there's a factor of 5 to go. I'm not quite sure how that will happen, but if you follow Wright's law and as to how costs fall as the volume of production increases. On most renewables, we are only a small distance into the journey towards a complete global market, and historically costs have always carried on falling. So the race is to get really smart at driving down cost, and there are lots of elements to it. Brilliant engineering, there's a big role for scientific innovation. A lot of the technologies we use are still way off what the second law of thermodynamics said they could be. So it was on the video, but Ceres, it's so exciting that Ceres seemed to have they made a big step towards getting rid of the inefficiency of electrolyzing water to produce hydrogen. That's a really big deal. And then Europe has been pretty good at financing these projects, and it's those 3 pillars of science, engineering and financing that are driving costs down. If we can really push costs down, it becomes affordable globally, and Europe is well placed to do some of that.
I think there was a positive in there, which we definitely need after hearing about all of these challenges. Pippa?
Yeah, I think some more positives. So, when we look at company origination in the clean tech space, like the US is North America as a block is has the biggest number of companies being created, but outside of that, China has got a lot going on as well. But it's actually Europe, and within that, UK is more than half of all of Europe in terms of companies being started in the clean tech space. So we are punching above our weight as a country and as a block. globally. And I think, that still does attract capital, and it still does attract talent and interest. We just need to make sure that we don't lose our focus on the importance of that with all the distractions going on with politics. That is, making more of a headwind when we really need the tailwinds.
It's a good point. It's a bit of a political kind of football at the moment, right? And especially going into the general election next year. So Pippa, while we're on the subject of capital, we have a question here. So do the panellists believe we have the senior talent within UK VCs and financial institutions with the domain expertise needed to deploy capital into clean energy at the pace we need? Clearly not an issue at your place, but more broadly.
It's a great question, because there's a lot of VCs in this country who are used to investing, as I said, in fintech and cyber and software. And this is a physical problem that we need physical innovation to solve. I'm not saying software, AI, data, sensors, they all play a part, of course, but it's not going to be enough, and it's only going to be a small, in our opinion, small part of the package of solutions that we need. So do VCs have expertise in deep tech? Most of them don't, right? And a lot of them are kind of scrabbling to build that. And then struggling to actually invest in the companies that they need to, even though they're saying they want to, because they can't get it through their investment committees. They're still kind of quite risk averse. So we definitely see that imbalance, and there being a big gap that I think that if VCs don't kind of step up, there are a lot of other countries, the US, Germany, for example, they've got a bit more of an advanced attitude towards investing in hard technology startups. And we'll miss the boat.
Mm-hmm. And what do you think on that point, Caroline? Because obviously now, as a listed company, you don't have to rely on VCs. Is that a relief, frankly?
Well, we've been listed on AIM before, so we weren't just new to being listed. But it is, I'm listening to this and you think, it's the investment in long term that we need for a lot of the technologies that we're doing. I think we were discussing before the panel that the UK can do that in the pharma industry, but we need to do it in other areas, and green technology is one of those. And actually, there's many skills that we may still need, but we're really good at advanced materials, for example. Something that this country does really, really well. We have to foster that, but that is something that takes time. All these timelines that I was talking about before, but they're worthwhile. They need doing. They need some people to do that. So we do need to adjust that length, that green financing, having that timeline to it. And I would say also in terms of the financial industry, there's also some, you were talking about permitting, and I suspect there's also some insurance changes that need to happen to also do this, because there's a lot of people worried about hydrogen, right? And you hear that all the time. Actually, we've been handling hydrogen for a long time, but somehow now it makes it into the news and people are really worried about it and so on. And we will need to also think about these other instruments for backing quite new technology and ensuring that there's confidence in the market. And there's a lot of financial instruments that need to come in, and they need to be in place, and they may not be in place by the time they really need it. So how do we accelerate that?
That's a really good point. I think something like insurance. So one of the biggest gaps we see, apart from the very early stage, is that sort of Series B, sort of first of a kind plant kind of stage of growth. That's where a lot of companies really struggle because they can't get project financing for new ideas. So that's something where insurance can help to offset some of that risk. And government support also goes a really long way. So we've got some great support there in the EU. We're hoping that we'll see some other sort of venture debt type mechanisms in the UK.
And what I'm also hearing here is about kind of getting the narrative right and talking about, kind of talking up our success as the UK, and obviously the media plays a role within that. We have a question here: how can we as engineers best articulate the facts to decision makers that we have already reached the position that it is no longer economy versus environment, but economy and environment, just as we no longer live on flat Earth? So, but Mercedes, that makes a serious point, doesn't it?
I think it goes back to getting messages about this is an opportunity. I think we need to be realistic, but we need to be optimistic as well. And I think sometimes maybe we go too much with the doom and gloom of, how difficult everything is. And I think we did a lot of doom and gloom tonight, I'm afraid. So I think we really need to step up ourselves in terms of being more optimistic that we can do it, that we need that support, that we need those mechanisms that we have discussed as well. But this is not a lost battle. Or maybe it's a lost battle, but we haven't lost the war sometimes, right? That's the way, that's maybe how it feels. And I think we need to be projecting much more positive messages because the technologies, as we've seen with Ceres Power, they can make it. We do have some of the technologies that we need. We don't have them all, and we have a number of them not mature to the scale that we need them. But I think it's projecting a message that we can do it. We need the support to make it happen. And we are running out of time. So we need to speed up quite a bit. We need to accelerate a lot of what we are doing. And I think sometimes it's maybe a message that is projected around, we're never going to make it, right? It's just, and particularly, and I think it's true, and I'm probably a bit of doom and gloom myself. I think it's true when it comes to these interim targets, the 2030 target, that's really difficult to meet. And it's also because it's the critical one at the same time. The 2030 is that 50% reduction emissions. Forget the 2050. Forget the 2050 actually. And it's really when you start doing this analysis and you realize how difficult it's going to be this 2030, because we are just only a few years, when you really think about, okay, we really need to step up the game here, because we cannot miss that one. And I think that's really the message we should be projecting. It's a message of optimism. We can do it, but we are running out of time. So we need to actually get a good push to be able to meet 2030 targets.
Thank you for bringing some much needed optimism. Richard, it's sometimes called the war for talent, somebody writes, but how do we stop fighting for talent and attract enough people into STEM to ensure there is enough talent to meet all our needs? And it makes a serious point, doesn't it? Because there's this whole race to the bottom or the top, depending on which way you look at it at the moment, with companies just paying more and more for the same skills, and that doesn't help anyone in the long term.
Well, the UK has been and should remain a very attractive place for global talent to land. I mean, it helps that we have a language which is the universal language for science and engineering.
And you're growing brilliant minds at your institution, for example.
Well, yes, but they come from all over the world. They always have done. I mean, if you sort of look at why British universities are very good, it's because they were international more than a century ago. And that is the culture. So we have to look internationally. We have to presume that we're going to attract talent in. I mean, a lot of our own students end up in the USA still. The brain drain still happens. It's a sort of dynamic equilibrium. That's what thermodynamics tells you has to happen if it's efficient. So we have to be attractive. We can do that. There's some steps that have to be addressed quite seriously now, but there's no reason why we can't be successful.
And we've got here a question about what the top 3 asks to government would be to support our net zero journey. So would one of those be around, at least one of those be around skills?
I think it is, and I think we have to look at what sort of infrastructure that needs to be in place to be able to attract inward or local large-scale investment. And it does require some thought. It does require looking at what has been shown to work elsewhere. I mean, if we've had a debate about the UK semiconductor industry, which is not large, and there are some bits that are absolutely brilliant. You don't need to go very far away to the Netherlands to find an extremely valuable company, ASML, which is it's the 3rd most valuable company in Europe, which produces the lithography tools that TSMC and Intel depend on. It has benefited, I presume, because the R&D centre in Belgium at Leuven, IMEC, has always attracted all the big global players in semiconductors. The Silicon Roadmap was alive and well there. That is the sort of attractor that brings the companies in, sets the standards, provides the information that allows local companies to get going, that's a success story. I don't think we've really addressed that issue in the clean tech space in the UK. We lost a lot of the national lab capability when the utilities were privatised back in Mrs. Thatcher's day. So we don't have national labs in solar. We have a bit in wind, but these are things that are going very strongly in Europe, and it makes a difference. One can see where companies are drifting towards where there are these centres of competence.
Blimey, so we've covered Brexit and now Thatcher. I feel like we've covered quite a lot of ground here. Just a final positive note. Ceres Power, obviously, is this year's winner of the MacRobert Award. Just give us a couple of thoughts on why they're such a worthy winner.
Well, they keep on being brilliant. But the big thing about the MacRobert Award is there's some wow factor about the engineering, and things that you didn't think were going to work turn out to work. So the original idea back at Imperial College more than 20 years ago, using gadolinium-doped cerium oxide as a relatively high mobility oxygen transport medium, to be technical, showed quite a lot of promise. It's taken 20 years to iron out the things that didn't quite work right. It's all there in the patent literature. We had great fun looking at the patent literature. And there's a brilliant one, it's about halfway through the journey. Can I be technical for a moment? Looking at my,
sure,
yes,
be my guest,
yes.
But I might get told off if we're too much over time, so keep it brief.
Okay, so there's a problem that what you want with these fuel cells or electrolyzers is that you can ions move through the membranes, not electrons. Otherwise it short circuits. So there's a problem with this ceria that if it loses some oxygens, which it can do, it becomes electrically conducting and short circuits itself. And there's a brilliant blocking patent, as I understand, with an extremely thin layer of zirconia that can be put in the right place in the stack that just keeps it insulating. It's a brilliant idea and brilliant execution. That's one of many, many examples. So this isn't a one-shot, silver bullet moment. It's a whole series of really good innovations that collectively is just mind-blowing. It's,
Wow.
It's so exciting to hear about it.
Mind-blowing. Well, you can't say better than that. So that does bring us to the end of this evening's fascinating discussion. This is such a vast and important topic, and we could have talked about it for much longer. So thank you for all of your contributions. I hope you all learned something new. I know I certainly did. Next year will be the 55th anniversary of the MacRobert Award, and nominations for 2024 are now open. You have until the 31st of January to enter. So if you know of any exceptional companies, or perhaps you run one yourself, please do encourage them to apply. And full details are on the Academy website. And those of you who are here will see QR codes dotted around the room that can direct you to further information. This evening's event is the second in the Academy's Innovation Incoming series, and the first was hosted by my brilliant colleague at the Times, Katie Prescott, and that's available online for you all to watch now. So it does remain for me just to thank our panellists this evening. So Dr. Caroline Hargrove, Professor Sir Richard Friend, who we thank for being our token male this evening, which is exactly how it should be at more events. Professor Mercedes Morato-Valla, thank you so much, and Pippa Gawley, thank you for your insights and expertise. And on behalf of the Academy, I'd like to thank the MacRobert Trust and the Worshipful Company of Engineers for their generous support of the MacRobert Award and this evening's event. Our guests here at the Academy are now welcome to join us for drinks. Please do stick around, and we'll say farewell to our online audience. So thank you for joining us, and good night.